And now I will finish questions 22 and 23. We were determining which of these are polar. When we drew the Lewis structure for xenon tetrafluoride, there are 36 electrons. I've distributed 32. We put the leftovers on the central atom, 34, 36 electrons. And as I look at this, there are a total of 6 groups of electrons around the central atom. Since there are 6 electrons around the central atom, 6 groups of electrons around the central atom, we know that the electron group geometry will be octahedral. Here's the octahedral shape. But we have 2 groups of electrons. If I put one group of electron here, because lone pairs are more repulsive than bonded pairs, the other pair goes here. And as I look at this, this is square planar, which is perfectly symmetric. Since it's perfectly symmetric, this is also a nonpolar molecule. This is also a nonpolar molecule. So the answer must be E. Let's go ahead and draw the structure of sulfur dioxide and talk about why it is polar. So for sulfur dioxide, and I'll just draw it right down here. Sulfur has 6 valence electrons. Each oxygen has 6. For a total of 18 electrons. When we distribute the electrons, sulfur is the central atom attached to 2 oxygens, 2, 4, complete the outer octet, 6, 8, 10, 12, 14, 16. We put the leftovers on the central atom, 18. The central atom does not have an octet. I'll erase a pair of electrons and put a bond here. How many groups of electrons are around the central sulfur atom? Remember, a double bond counts as one group. This is one group. This is one group. There are 3 groups of electrons around the central atom. And yet when we put a lone pair on, instead of the central atom be attached to 3 atoms, it's attached to only 2 atoms, and it's got a lone pair. When we name the molecule, we name it based on where the atoms are, not the lone pair. So here's the shape of the molecule. The shape of the molecule is bent, and the angle is approximately 120. It's a little bit less than 120 because of the lone pair here. Now, as I look at this, oxygen is more electronegative than sulfur. There's a partial negative here and partial positive here. This oxygen is more electronegative than sulfur. There's a partial negative and a partial positive. So this molecule has a positive side and a negative side. The positive and negatives do not cancel out. So this is a polar molecule. So the correct answer to number 22, the polar molecule, is choice E. Okay, we have one more question. What is the shape and polarity of the beryllium dichloride molecule? Okay, so as I look at beryllium dichloride, let's draw the structure. So BeCl2. Beryllium has 2 valence electrons. Each chlorine has 7. So 14, that's 16 electrons. Beryllium is the central atom. It's attached to 2 chlorines. 2, 4. We complete the outer octets first. 6, 8, 10. 12, 14, 16 electrons. That's all 16. Now remember, there are 3 atoms that routinely have fewer than an octet of electrons. The 3 atoms are from the periodic table are beryllium, boron, and aluminum. I write it like this because that's how they appear on the periodic table: beryllium, boron, and aluminum. Beryllium has fewer than an octet, and that's what we typically see. How many groups of electrons are around the central atom? There's 2. Therefore, this is a linear molecule. The bond angle is 180 degrees. Now, if this is linear, is it polar or nonpolar? So here's this linear molecule, 180 degrees. Chlorine is more electronegative than beryllium. We could depict that fact using a vector. Chlorine is pulling the electron density away from beryllium, and this chlorine is pulling the electron density away from beryllium. This molecule has polar bonds, but the polar bonds cancel out. When you add those 2 vectors together, they are equal in magnitude, opposite in sign, so this is nonpolar. So this molecule is linear and nonpolar, and so the correct answer to 23 is choice A.